Hello, YouTube. Hello, Zoom. Hello, Room. It's our last lecture before the holidays. This is really an orientation session for the test, which is to come in the next couple of weeks. So I've got a lecture page. Um, I don't quite know why it is, but it was Alistair who started it. That tests are always referred to in rhyming slang. So this is the doubtful guest. We've had Belhaven Best in the past and various other things. Um, uh, okay, so I have spent this week um, trying to cobble this test together. There are going to be, so there's a test page, which I see about a tenth of you have found, and there's a bunch of puzzles. I've managed to set the first three of these. The last two are still in the works, but they will drop before Monday, I promise. Um, okay, so crucially, you will need a password, and the password is score a goal to access the test problems. The reason why there's a password is so that I can. There are multiple passwords. There are secret passwords that I'm not going to tell you. Yours is the public password, and I can switch off access depending on the password, which means that Clemens and I can experiment, try out the test problems without giving you access to them. So that's what's going on there. So my plan is to activate the passwords. Well, I mean, basically as soon as stuff is ready. So we'll get there. We'll get there very soon. However, what I wanted to do in this lecture was to take us through an example of the experience of doing a test puzzle, just so that you know what to expect. And maybe we'll get a little bit of practice while we're about it. So, and if you've got your laptop there and you want to play along, that's absolutely cool. Please do. Okay, so let's go in to this puzzle, which is a retread. Oh, I can't find it from last year. Um, but I've just freshened it up to this year's notation over my morning coffee. So what I'm going to do now is to click activated on the password for the students. Right, I get the staff only controls. So does Clemens, because Clemens also counts as staff. So I can make this test active. And now, Clemens, I will stop sharing and I will pin you if you will share your screen.
Okay.
Can you share your screen?
Can I share my screen?
Or at least your browser?
It's one of the famous. 1 second. Share screen. I'm just sharing the screen. That's easier to see.
Right.
But how do I get rid of all this clutter?
That one. And I think there's a hide floating meeting controls is available from more, if you're lucky.
Okay, now I'm sharing something weird. Okay.
Right.
Sorry, give me 1 second.
Hide,
Optimize for video sharing.
maybe. um, you were sharing a moment ago. Maybe you'll be sharing again very shortly.
Says that I'm sharing.
Right. We can see we can see your browser. You've just done a git pull.
And I don't know why I did a git pull.
Yeah, you might.
How did I get rid of this bloody thing? 1 second.
Anyway, why don't you hide the floating meeting controls?
Yeah, but how?
It's on the menu.
Ah, perfect.
Right.
I already failed in the first stage. Okay,
No, you want to hit the back button, I think.
let's go with the back button.
Right. Okay. So
Okay.
now you need to type
Score
a goal. No spaces.
No spaces, only goals.
Right.
Score a goal. And this password is currently deactivated. You need to
because I need to activate it.
Excellent.
I'm clicking on the Zoom screen. Right. So try again. Send again.
Wait, let me just reload, maybe. Wait a sec. Let's just briefly go back and.
Oh, you're deactivating it. That's the trouble. You need to set your radio buttons to activate it as well.
Excellent.
That's the trouble. I was activating it, but because Clemens' radio buttons, he was also setting the controls and undoing the very thing I'd just done.
Do I have to press send?
Yeah.
Okay, let's press send.
Right.
Hey, now
we've got a puzzle, and it's a lot like the tutorial problem situation. But hang on, I need to bring Zoom to the front. That's you now, not me.
Indeed. Better would be if you could make it full screen, but anyway,
I can do that. Enter full screen. All right.
Okay. So it's indeed very much like the tutorial. To be honest, I don't know what's coming now because I did not check it in the morning.
But that's the realistic experience.
Because Connor said I should be just really like now student logging.
So
here we go. So we have the plus defined, we have the times defined, and a few other things. What's the double? What does the double do? It just doubles.
Yeah.
Okay, excellent. So it just takes times 2, I guess.
Yeah.
So because 0 goes to 0 and 1 goes to 2, I mean, and then further. And then what's next? The full gives us full of S of it's the S of double of full. What does this do?
Right. So this is also the authentic experience, right?
Indeed.
You should expect questions to begin with a definition and to think, what the fuck's that?
That's the thinking, to be honest.
Yeah. So it's at each step we double and add 1. Think about what that does in binary.
Oh my God.
Right. It's set, carry, flag, rotate left in CS103 speak. But
I never took 106.
Yeah.
Here I am, but maybe somebody can help me out.
Well, so give it a go, right? You can run this program in your head. Full of 0 is 0.
0 is 0.
Yep.
Full of 1 is what's full of 1?
It's 1 plus double 0.
It's probably 1.
Yeah.
And full of 2 is double of full of 1, which is 2.
Plus another 1.
Is 3.
Yeah.
Okay. So we get just the full, right? Okay. Full of what's 3?
Full of 3 is
6, 7.
Yeah, is 7. Full of 4 is double 7 and add 1, 15.
I see.
So it's called full because full n is the n-bit binary number that's all 1s.
I see.
And it's not a very popular operation, but I love it. And I mean, it's the thing that computes -1 in the n-bit 2's complement representation of -1, if you like that sort of thing. Anyway, the other thing, of course, you can do is read more of the question.
Indeed.
Right. So notice that we give you. So there'll always be a library of stuff. So you don't have to rebuild everything from scratch, same as in tutorials.
Exactly like in the tutorials.
Yeah. So I just give you a list of things that you're allowed to use, and you should always pay attention to them. You'll notice that for the first time this semester, multiplication is commutative. And you may be wondering, Why has that dog not barked before? Think on that. So,
I see. Okay. And now we come to the first part. So this is the first, the question has 5 parts. The first part gives you 2 marks.
Yeah, I think I just numbered it wrong. There are actually only 4 parts. So it's me doing dreadful copy pasta. But
I guess that's all right for the test. I mean, for the test of the test.
Yeah.
This is now indeed the first part, which would be 2 marks because you have to define the power function. And then I think that's just defining the power function.
That's just defining the power function. I'm just trying to be super generous, basically.
Well, I'm not sure whether I can define the power function, but let's see.
Well, you've got multiplication.
That's already something.
That's
So how do we define the power function? X to the n. Sorry?
From n.
From n, indeed. Well, maybe before from. Indeed.
Yeah.
Let's do the inductive.
We're going to do, exponentiation is repeated multiplication.
And we know what it is for n equals 0.
Yes.
And then can work our way down to there somehow. Okay, so this is exactly like in the tutorial. And now we do the from. And then we accept. And then we just have to say what it does. X to the 0 is equal to.
It's
early days, but luckily I think I know.
Yeah. Well, in any case, you'll see further down that you're asked to prove that power x is a monoid map from plus to times. So
further down, sorry.
Yeah.
Here.
So where should you be sending the neutral element of addition? You should be sending it to the neutral element of multiplication.
Indeed.
Yes.
And the neutral element of multiplication is
1.
Indeed.
So go for it.
I think x0 is fine as okay.
Yeah.
Sorry, it is s of.
Yep.
1 or sz as we know it.
Yes.
Okay. And now we have to do the inductive case. So suppose we know already what the power of x2. Okay, let's call that not x0. It looks horrendous. Let's call that m, I guess.
All right.
And then we just said we know what the power of x to the m is. So somehow we use this.
Yeah, you'll just smash your fingers. Yes. We all do that.
Excellent. Power x to the m, that would be a boring definition if you would put it would be actually defined if I press now. Maybe I just define it now.
Yes.
To make it says defined, but sadly defined doesn't need, I mean, how to say it, doesn't need to be correctly defined, right?
Yes, it says that's our function, doesn't say it's the right function.
Indeed.
I give you a little bit of test data.
We can do a test here. And then suddenly we have to prove false, which is not a good sign.
Yes. If you're ever asked to prove false, you're in trouble.
So something is wrong with the definition.
And I think you forgot something.
I forgot something.
Your function is a very complicated way of returning 1.
Indeed.
It
goes all the way down and then says 1.
It's still 1. Yeah, it's still 1. You want a different number?
Now the question, however, is a bit tricky. I mean, there are 2 definitions which both work. I don't know whether there's a subtlety here.
So
we could do it on the right or on the left.
Yeah.
Probably I want to do it on the right.
So that would be my suggestion. So yeah, subtlety here. Okay, so first of all, it shouldn't actually matter. So it's worth not overthinking. If you want to do a little bit of thinking, here's the thinking that you ought to do. You go times, you look at the definition of times, and when I give you a definition in the library for the question, I always show you the definition so you can see how it works. Okay, so times is defined inductively on its second input. So if you're going to have something complicated like a recursive call, and something simple like a variable, and you're going to multiply them together. Put the simple thing in the inductive position.
Exactly.
Yes.
Okay, let's do that.
Right. Don't, it's always a good idea, right? Because if you've got a variable in the inductive position, you can from that variable to get some computation to happen. Whereas if you've got some complicated thing in that position, then you have to figure out how to make that complicated thing do something. So this is a good choice, but the other choice is not wrong. And what's more, the rest of the question will still work with the other choice.
Yes.
It's just that you might make things slightly more difficult for yourself. So
difficult.
yes, difficult, Clemens, difficult. Yes. Okay.
Let's go. And now the test.
The test works.
Also works.
Yes.
So
we just checked that 2 to the power 3 is 2 times 4. So is 8. So that's very carefully chosen because, I mean, I had to think about what to do. 2 to the 3 is one of the smallest examples that isn't completely trivial. And I had to be very careful. I didn't do 2 to the 2. Why didn't I do 2 to the 2?
Yeah, why didn't we do 2 to the 2? This is an off-mouth question.
Right, because 2 to the 2 is 4, and so is 2 to the 2. Whereas 2 to the 3 is 8, but 3 to the 2 is 9. So if you got it backwards, that'll show up in the test. See, I'm trying to be nice. No.
Good.
Yes.
So now we come, so this basically finishes this part of the test. And then you can move to the next question. I mean, you can move to the next question earlier already.
Yeah, I heartily recommend reading all the questions before doing any of them.
And more kind of submarine approach.
Yes. So in particular, if you look at the last part of the question.
Okay, let's look at the last part of the question.
You'll see a big clue as to what on earth is going on with full, namely that it's 1 less than 2 to the power.
Yes, because the successor of full happens to be 2 to the power.
Yeah.
Okay, fine. So this would have been so much easier
if
I
you
read the first, I mean, the last one.
So
it's good to read the full thing, as I just realized.
Right, yes, it's good to look where you're going. All right.
Especially if you don't know what a function does, because then you see what you have to prove about the function and you realize what the function does.
Yeah. I mean, that's the trick. I'm trying to get you, like, here's the thing. It's new to you, but at least it's properly specified. So it's for you to make sense of it. All right.
So now we need to prove something about the power, namely that it's a monoid map. Did you say that? Yes.
Yeah.
Okay, so let's see what we do. I mean, why is it stuck? It's obviously stuck because of the second argument. And the second argument is stuck because of the first argument. It's a bit tricky in the sense that the other side is stuck because of the B. So
yeah.
I could construct a stuck case for both sides.
Yes.
But the A keeps stucking two things. No.
Yeah. Yes.
That would be my choice now. But
yeah. So that's a good choice, especially as I've already given you a shed load of algebra, right?
Okay.
You've got all of the rig business for plus and times. So your business here is making power do something.
Okay, yes. So we do inductively A and send this over. Oops, accept. And then from A, presumably from A.
Yeah.
Okay, so this is now
truly ghastly name.
No, not X is not good. But
X is a bad choice.
Okay, I can call it Y maybe.
Yeah.
Prime should be always the last resort.
Yes. The alphabet's quite generous.
Indeed.
Sadly, emoji are not allowed.
Because you don't like Unicode.
Because I don't like Unicode.
Anyway, so let's see what this says. It says something about the power of successor or something. So there's some calculations that could happen right now.
Yeah.
So let's do that.
Sounds like a plan.
And then what did you get? You get something to prove. What is it? Power of x, y plus b, blah, blah, blah. What do we know? We know something.
Let's see. What do you like the look of here? Any suggestions for moves we might make? Yeah, well, that's just computed. You can see in the left-hand side of the goal, we've done one step of computation. Out has bubbled one of the x's. Yeah, so we've got there's a sub-expression of the left on the left-hand side that looks a lot like something the induction hypothesis talks about.
Indeed. So if you look at this expression here, power x, y plus b, this is exactly the inductive hypothesis because, okay, so we have, let me briefly copy this down or something. This is the induction hypothesis. If we write this with y, then this is what we are allowed to use.
Oh, you've lost times power xb.
I lost something indeed. Okay, let me copy this down again and do it properly. So where does the y go?
Instead of the a.
Here we go.
Okay. So we've got a handy fact which you could even neatly line up with the place that you're going to use it.
I could.
Yeah. Look at that. Right.
So this is calling for what?
Biroots.
Indeed.
We're going to just swap out the left-hand side of the induction hypothesis for the right-hand side. So, yeah.
Now whatever. I'm not gonna. This is the first thing times x.
Yeah.
And that's it, I think.
Yep. Looks good.
7. I forgot the question mark. Let's
classic.
not do the classic.
Okay. So you get two sub-goals. The first of which is just to justify that move that you made.
Which is usually done with the under.
Yes, so that's under times. That just digs out the place where we made the change.
Yeah. So this one is proven now. And the second one, we need to do some work, I guess, or not.
Yeah. Yeah.
Let's see. I can put this into a new line.
Yes. Okay.
Maybe it's easier to look at it here.
Yes. So
it's the same things, right? I mean, shouldn't the test do already the trick? Because we have don't we have?
But pay attention to the fixity declaration on times. So further up where the definition is, times is defined to group to the left. So if you put the brackets in, you'll see that you've just got things are just a little bit more fiddly than you want.
Sorry, so what do we have then?
You're grouping to the left.
So that means we have on this side this?
Yep. And on the right-hand side, you have that. Okay? So you can see that in the immortal words of Eric Morecambe, you've got all the right terms, but not necessarily in the right order.
But we do have associativity.
But you have associativity and you have commutativity, so you're just going to have to beat it to death with algebra.
Oh no. Okay, so I think this is calling then again for a biroot.
Yep.
And I would just re-bracket the right-hand side.
Yep. I mean, you're going to have to do both sides. It doesn't matter which order.
So, do I?
Yeah. Because the thing you need to swap.
I have to do two re-bracketings.
Yes, you need to re-bracket both sides and then you're winning.
Oh my God. So much re-bracketing going on. Wait. So we have to re-bracket. So we re-bracket.
Yeah.
So we do this, oops, and one more bracket.
Yep.
And we do a send.
Yeah. So that's got us. We now brought together the things that we want to swap round. And then
Indeed. And now, sorry, what do we do now?
well, you're nearly good to go, but unfortunately the left-hand side is still grouped the wrong way.
So we just group the left-hand side in the same way. Okay, good.
Yep.
So I have the advantage of having Connor next to me when I'm doing the exam.
Yeah, well, that's because I want it done before the end of the lecture.
Which might not happen, but let's
Yes.
see anyway. We're doing our best.
Well,
in the pluralis, whatever. Sorry, what
yeah.
do I have to do? Here, this one.
Yeah. Yep. You want to just group that away. And you're nearly there. Because now you can see
Under
that under times. You can see, well, if you just bring that down so we can see properly. You can see you've got two multiplications. The first inputs match on the nose. The second inputs had better be equal, and we know that multiplication is commutative. So under times is your
under times is my timeless friend.
yes.
Okay.
And you're there.
Yay.
So this is some another thing that happens is straightforwardly ask says proven, marks in bag, right? You know when you've won. Okay, good stuff.
Excellent. Let's go further. Part 3 of 5. The good thing is there are no 5. So
yes, there's only 4.
Might help us to actually finish
yes.
this. But let's not be too optimistic. So what do we have to prove now? The power of the power. Okay. It's like x to the a to the b.
Yeah. You know, it's stuff, it's high school stuff, right?
Is equal to x to the a times b.
Yes.
Where is it stuck?
Yes. Okay.
Sorry,
just want to look up a little bit. We will, of course, well, we do better than put this code up. You'll see what happens next. Right. Okay. So,
yes. Is it fine? I mean, you will see it later on anyway on the video and stuff. Okay, cool.
Well, I mean, moreover, there's stuff to come. Let's crack on.
There will be some special effects at the end.
Yes.
Okay, good. Which I have no clue about. Anyway,
Yes.
let's go. So this is basically, where is it stuck? It's stuck on the first one is stuck on the B, I would say.
Yeah.
And the other one is also stuck on the A times B, which is stuck on the B. So I think I go for the B in this case.
Good plan.
Okay. Inductively. B. Send. Set. From. Accept. Now we put here a Y.
You got one more.
Yeah, I just took the shortcut to
yes. Okay.
keep the suspense. Wait a second. Yeah, okay. So
that'll do some work.
Oh yes, we can do some work. This test. We can do some work because it's applied to successor. So we made some progress. And what do we have now? Here, okay, let's see. This thing here looks suspiciously like something.
Yeah. So yeah, you like that thing. Do you like anything on the right-hand side?
On the right-hand side.
I mean, I'm not trying to redirect you. You're making a valid point. But let's just take stock. There's power x of something plus something, and we know a song about that.
Oh my God.
So this is another thing you should expect, right? These puzzles are not a random buckshot scattering of goals. You should expect that the things that you prove in earlier exercises are the very things you need to solve the later ones. So
Yes.
each puzzle is also a clue for the next puzzle. Please take hints. Right. Yes.
So we have to do two things basically. Applying the inductive hypothesis on the left, and on the right, we have to take the thing that we just proven to split things up basically.
Yes, power will distribute through plus.
So let's do the distribution first, or what?
Doesn't matter.
It doesn't matter. Okay. Well, it matters to do something, but
Yes.
okay. Sorry. So this is now the this inductive hypothesis, which we replace with this thing here.
But you need its
Now
context.
I need to. Sorry, I need to change something
yes.
with y basically.
Yep. And then you need to put the rest of the context back, namely
Times power x. Yeah.
Okay.
And I hope this could work.
Looks about right.
Hmm?
So again, the first sub goal is just the justification of that move using under.
Okay. And the second one is now okay, 1 sec. It's almost there, right?
Yeah.
But we need to do something, I guess, to tell ask to turn this
Yes.
apart.
You
And
need
then we can use commutativity of multiplication somehow. Hopefully. So this is what? Power xa
yeah.
times power x. Sorry,
So
this is bad.
that open parenthesis is not good. Yeah.
No. A times y.
Close and one more close.
Close. Let's do this. And it's proven. Yes.
Right. Right. Because it actually just saw that what was the right to middle was the thing we just proved, and middle to left was exactly commutativity of multiplication.
Yeah.
So we're, no subgoals. Okay. That's very cool.
Indeed. Which brings us to the last but not least.
Indeed. So this, right, you see there's
oh my God, it might help to prove something.
Relating double and plus. And don't sit there trying to guess what that's going to be. Wait till it gets in your face, is my advice.
Okay, good. The other thing I would say is that it's both stuck on n, so at least that should be obvious.
Uh-huh.
Inductively n from n. And now we do the usual
Change
thing.
the names to protect the innocent.
Okay, let's see. Do we have some calculation to do? I think we do, right? Because the power can at least do something.
Yeah.
So let's just see what that calculation is. Sorry, I just should go to the next line. Sorry, what happened now? We have power. I might get stuck now.
Right. Well, do you see anything you like?
Not much at this stage. Let's see. Well, there is something. Let me see. This power here
Yeah.
is, of course, the right-hand side of the induction hypothesis.
Good spot.
So,
and it's got a friend. Yes.
What do we In what way? It's
Yes.
got a friend there.
So-
It's got a friend which also sits there.
Yeah.
It happens to be 2 times the right-hand side of the inductive hypothesis.
Yes.
Induction hypothesis. Okay, let's see. So let's try to apply it, right?
Yeah.
Okay. Oh, by root then. But now what? Power? Oh my
Well,
God.
you need the left-hand side of the induction hypothesis, right?
What's the left-hand side? It is basically S full of Y.
Yeah. So you need to build something, that thing,
Plus.
and then careful to get the bracketing right. And you want that to be a Y.
Uh-huh. Good. Thanks.
Okay, so that's progress.
If it works. It seems to work. At least
Okay, you'll need to do some undering to
yes.
okay, and to do the undering, you will have the annoying experience of
You mean here I need to do
yes,
some undering.
and you need to be a little bit careful. So this is the subtle point.
But isn't it bracketed? I mean,
It's
I can do first some undering to get rid of this.
so the trouble here is that Ask has only gone and computed this plus a little bit.
Yeah.
So if you want to do the undering, you need to do that computation. You need to undo that computation step.
Oh, bloody hell. I know what you're talking about.
See that success, there's a successor on the outside, and you need it not to be on the outside. You need it to
On
be
the inside.
on the inside, like that. Now you can go under.
I see.
Yes. So that sometimes happens. Ask does too much computation. You have to just undo it in order to line things up for under. You've seen some examples like that. To hit send, and you'll need another. And again, you have to undo a computation to expose the plus in the right place. Okay, so you've justified the step. Now you've still got one sub goal left.
And this is probably now, this looks awfully like a thing about double, maybe. Are we not there yet?
You're not quite there yet. You've got there's a couple of things you're close to. You've got that bloody annoying plus Z. So,
can I just remove it?
No, you can't, because it's on the right of a plus, but you can by root it out of the way, right? You can algebra that Z to death. Yes.
By root. Let's just copy this.
Or you can even there's a bunch of ways you could get rid of that.
Okay, this was the worst button that one can press. It's not the very worst. Let's not ask fate.
You're on the right track.
But where am I?
You're just down there.
Sorry, where? Oh yeah, exactly. Thanks.
But you've got to fix your bracketing.
I think now the bracketing is all right. Let's send. Okay, sorry. Let's kind of make it a bit nicer here. Send this off.
And you'll need the second sub goal you'll need to just under to
yes.
To sort that out.
Under plus. Sorry, this is the second sub. Second sub goal. Under plus. Let's see what happens. So this one is proven now. So that brings us here to the double of full. What should we look at the definition of full, or what to understand what's going on? Or
well, no, you've shot your bolt there. I mean, okay, couple of things to notice.
It's easy in a way. No.
I
can pull the S on this side here out.
Yeah.
Then I have the successor of full of y plus full of y, which looks very much like the double of full of y.
Yes. So we're about to figure out. So yes, that's a good move. So do that move, see what you see.
But do I have to do it, or is it just a?
You have to do
You
it
have to
because
do it.
plus only bubbles successors out from the left.
I see. Okay, so this is then S of whatever it is, full of y plus full of y. Ah,
You
now I hit the revert button. Very good. The revert button works, I can tell you.
too well. Um, yeah, you want to move that S to the front.
Indeed, sorry, let's. It was working fine until I suddenly thought by myself I'm running out of time. So then, okay, let's see. I think it looks all right or not. Yes, so we now are stuck with this.
Yep. So that's double of something is thing plus thing.
Yes. So we want to prove it separately, or
Good plan. Right? It's got nothing to do with full anymore. It's just a fact about doubling something is the same as adding it to itself. Yeah. Right. And then you should be able to just say given for
wait.
that one.
Given.
Yeah, you could replace this question mark by given.
By this one here.
Yeah.
Okay.
And you see, it hasn't turned to proven, but it's stopped asking questions because if we knock off this new proof, we'll be winning.
Yes, so we just have to prove this here now.
And there's
I might not finish it, but maybe it's not too bad if I don't finish it.
it's not lethal.
Because wouldn't it even allow you to show something?
Yeah, and then
Almost.
yeah, now you need to say what to do. Yes.
Wait, I'm guessing now I can compute something.
Yeah.
Ooh. Send, accept.
Mission accomplished.
Wait, mission accomplished?
Oh no, nearly.
Nearly, but we put the S out. No.
Oh, you can't do that. You
What?
can't move the S.
Okay, where was the S first? This is this one.
Yeah.
So I need to do a root.
Right, but you can use the induction hypothesis for sure.
Ah,
Yeah.
indeed, double Y gives me an induction hypothesis. By root S of, and then it's Y plus Y. Send
And
proven.
it is completely all done. Hit accept, and the shut up alarm has happened. That's good. Okay, so Clemens has finished the problem. Fantastic work. Now you should stop sharing your screen for a moment.
Oh, where do I get the control space? Okay,
uh,
I already stopped sharing. No.
okay.
How is this possible?
Um,
What do you see here? Is it my or your screen? It was always your screen.
yeah, this is my screen,
Indeed.
but now I was still seeing you. I need to stop being in full screen mode. Right, we're not done, folks. Hold your fire. Right, now we're back on my screen.
Good.
And I'll show you what happens next. Is right, the test's over. Now I switch mode to markable. All right. Now, Clemens, let's share your screen again, reload the page.
Share the screen again. Yeah.
And I should be on
see.
Zoom.
Reload the page.
Yeah, hit send again.
Okay. Second. I hit send again.
Yeah. Okay. So now you should find, if you scroll down, that you can no longer edit in the edit boxes.
Indeed.
They're now read only, but further on down, you will find some test data, which is only for staff. But you can see what's going on here is that I've got a bunch of tests there and I'm checking some equations. You can see I'm interested in whether I'm tolerant of either way around of defining power. And you can see that we attempt to prove the same things again, given. And the plan here is that if you've done your job, proof by given will work. So this is how we do some marking. Carry on down the page.
That's the bottom.
That's weird. This worked for me. Is it because you're staff? This shouldn't be happening. Oh, I know what it is. It's the same thing again. Can you go to the
okay.
Can you go to the top of the page and make it markable yourself? You again undid my maneuver. Right. Now I hit send.
Now it's markable.
Now it should be markable.
Let's see.
And down the bottom, you get a load of specimen solutions.
Yes.
And you also get some checkboxes. You've run past some of them.
Sorry. Okay, let's go up.
All right. Yes, I need to.
Here.
Yeah. So you see, what happens is that you get a bunch of checkboxes which make statements about your solution. And what you have to do is check the boxes which apply to you. So why don't you do that? I think you've done everything right, so you should just check all the boxes.
Fantastic.
Yes.
My power function. Okay.
Yeah, you get specimen solutions, you get all of this stuff.
So for all of the exercises, you have to do this basically. I used my induction hypothesis. I used
That's
loads of things I did.
It's even all true.
I proved that full is 1 less than 2 to the power. Yes, that I did. I worked inductively on it. Good.
Right. And now you hit send. Okay. And now look at what's come back in the checkboxes. So you see, you get marks already saying, we agree to check this box, right? Some of this stuff is automated, but some of it's not. If you keep on going down, then some of the checkboxes need human attention. What that means is that there's no automation for that checkbox. So somebody who might be me or might be someone I pay has to go in and double check that. So let me show you now what happens next on my screen is that I go
on your screen, yes.
and
but that's not on Zoom now.
yes, okay, fine. I will do that. I will share my screen.
Yeah, please do.
Replace current share with Firefox. We're nearly there, I promise. So here I say Snoop is hopefully if I just say cookie, it'll work. Right. Now I'm snooping on Clemens cookie. And I get a second column of checkboxes, which are the official ones. And they are initialized either by the algorithm, by the automatics if there is one, or from your checkbox answers if not. So all I have to do is fix up the lies you told, except that you didn't tell any lies. So all I have to do is press send. Okay, and now, Clemens, I'll stop sharing and you can reshare and
sorry, how do you share
and hit send again. And if we're lucky, down the bottom of the page.
Down on the bottom of the page.
You've 10 out of 10! So well done, Clemens! So that's the process, folks. I will send around. Well, actually, tell you what, folks. Tell you what. At least for these three, bam, 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 I will activate, activate, activate. All right, folks, best of luck. I'll be in touch about the other two puzzles. Don't be a stranger.
It's still recording.